Hey there! Welcome to 1% English Podcast, the daily English show that trains your ears and your brain just 20 minutes a day. Today, with our two hosts, we're going to answer the question, should we eliminate all mosquitoes?
Today, we're diving into a question that touches on, immense human suffering, cutting-edge science, and some pretty profound ethical considerations. Given the devastating impact of mosquitoes on global health, should we actively pursue their elimination? Or do their ecological roles and the potential for, unforeseen consequences demand a more cautious approach? This complex issue draws on a rich tapestry of expert perspectives and research, from scientific features in Nature to analyses from TED-Ed and DW Planet A, and discussions in forums like R Change My View. I will be presenting the case that targeted elimination of disease-carrying mosquito species is not just scientifically feasible, but a moral imperative, driven by the vast benefits to human health and economic stability worldwide.
And I will argue that while the human cost is undeniable and deeply tragic, the intricate ecological disruptions and the, frankly, significant ethical implications of driving any species to extinction are simply too great to ignore. This is a truly profound dilemma, isn't it? I'm eager to unpack its many layers with you.
Absolutely. From my perspective, the core insight driving the argument for targeted mosquito elimination is a utilitarian imperative. The immense, measurable good of saving millions of human lives demonstrably outweighs the projected minimal or perhaps temporary ecological ripples from a focused intervention. Mosquitoes, after all, are undeniably the deadliest animals on Earth, responsible for over 700,000 human deaths annually. That figure tragically surpasses the death caused by any other creature, including humans ourselves. Consider malaria alone. It infects approximately 247 million people and tragically kills nearly 1 million each year, predominantly children under 5 in Africa. Beyond malaria, these tiny insects transmit devastating diseases such as dengue, yellow fever, Zika, and West Nile virus. It imposes a massive medical and financial burden globally. When we speak of impact, this is an unparalleled public health crisis. Many scientists, even those, deeply involved in mosquito research, believe that the ecological impact of eliminating only the harmful species would be minimal or temporary. Joe Conlon, an entomologist from the American Mosquito Control Association, suggests that ecosystems would merely pick up and then get on with life if these specific vectors were removed. This speaks to nature's incredible resilience and adaptability, doesn't it? What's truly promising is that recent scientific advancements offer incredibly precise and effective ways to drastically reduce disease without affecting all 350 mosquito species. We're talking about technologies like Gene Drives, which are essentially genetic editing tools designed to rapidly spread specific traits like sterility through a target population, or the use of Wolbachia bacteria. Now, these bacteria don't aim for extinction at all. Instead, they essentially make mosquitoes immune to the parasites, blocking the virus's ability to replicate within the insect and thus preventing disease transmission. A truly elegant biological intervention, really. For example, trials in Colombia have demonstrated a remarkable 95 to 97% reduction in dengue fever using Wolbachia-infected mosquitoes. The overwhelming human benefits saved lives, reduced healthcare burdens, increased economic growth in affected regions makes the targeted elimination of these vectors a moral and practical imperative.
I understand the compelling humanitarian argument you've laid out. The suffering is indeed immense. However, when we propose to eliminate a species, even disease vectors, we must proceed with profound caution. We're talking about interfering with an intricate web of ecological dependencies that has evolved over 100 million years. To intervene so drastically risks unforeseen and potentially catastrophic consequences that could ripple far beyond our current understanding. Mosquitoes are often profoundly misunderstood. They play crucial roles in various ecosystems, each occupying a distinct niche, its unique role and position within the environment. For instance, in the Arctic tundra, species like Aedes impiger and Aedes nigripes constitute a massive biomass. They are not just a food source, they are a primary food source for migratory birds, and their sheer abundance even influences caribou migration and nutrient cycling. Some estimates suggest migratory bird populations could drop by over 50% without them. That's significant. Their larvae are also significant filter feeders in aquatic environments worldwide, processing organic detritus and serving as food for countless fish and predatory insects. Take the mosquito fish, Gambusia affinis, a specialized predator so effective at eating mosquitoes that it's often used in pest control. Without mosquitoes, such a species could face extinction, causing a further trophic cascade.
Furthermore, adult mosquitoes are pollinators for thousands of plant species, including some tropical crops. While perhaps not crucial for human staple crops, their loss could have unforeseen consequences on the reproduction of delicate plant communities. This brings me to a critical concern: unintended consequences. History is replete with examples, such as the introduction of cane toads in Australia, where human interventions, even with the best intentions, have had disastrous, unpredictable ripple effects far beyond their initial scope. Removing mosquitoes could leave a vacant niche that a new, potentially more harmful organism could occupy. Beyond the ecological, there are deep ethical questions surrounding humanity's right to edit nature and intentionally drive a species to extinction. This would mark a new threshold for humanity, potentially devaluing the sanctity of life itself. Decisions of such magnitude demand broad, inclusive consultation that extends far beyond just the scientific community.
That's a valid concern regarding unintended consequences and the potential for a vacant niche. Yet my perspective highlights a different facet of that risk. While the sheer biomass of mosquitoes in certain areas, particularly the Arctic, is indeed notable, most animals that consume mosquitoes are generalists. They are opportunists, not exclusively reliant on one food source. Richard Merritt, an aquatic entomologist, observes that most insectivores wouldn't go hungry. They would simply switch to other abundant insects, like, say, midges. Stephen Giuliano, an insect ecologist, reinforces this point regarding their role in aquatic environments. He suggests that mosquitoes aren't uniquely important filter feeders in most systems. He uses the rivet analogy, where an airplane wing might have many rivets holding it together. Removing one rivet, like a mosquito species, might not cause the plane to crash because there are many other species performing similar ecological functions, ready to compensate. It's also crucial to remember that we're not talking about a total mosquito apocalypse here. Of the 3,500 named mosquito species, only a couple of hundred bite or bother humans, and even fewer transmit deadly diseases. Targeted elimination of these specific vectors, like Anopheles or Aedes, would leave the vast majority of mosquito species untouched. Kathy Kirby, a wildlife biologist, even suggests that in the Arctic, midges are often a more important food source for birds than mosquitoes, which humans might overestimate due to our singular attraction to them. So the ecological niche is likely much more adaptable than it appears at first glance. What are your thoughts on this idea of ecological redundancy, especially when we're focusing on such a small fraction of the total mosquito population?
Okay, well, while I acknowledge the concept of ecological redundancy and that some predators are generalists, I find it difficult to accept that the ecological scar would heal quickly and seamlessly in all cases, especially given the scale of the intervention proposed. You mentioned the Arctic, and it's a prime example where the sheer biomass of mosquitoes is exceptionally rare worldwide in its abundance. They are not merely supplemental food sources there, they are foundational. Bruce Harrison, an entomologist, estimates migratory bird populations in the tundra could drop by over 50% without them. That's far from a minor hiccup.
Okay.
Furthermore, the rivet analogy, while illustrative, can also be misleading, can it? Some rivets are more critical than others. Beyond the Arctic, consider the intricate, tight-knit communities found in pitcher plants. Here, mosquito larvae play a unique and indispensable role in nutrient cycling, breaking down organic matter and influencing microbial communities. John Atticut's research, for instance, showed greater protozoan diversity in the presence of mosquito larvae as they help keep dominant protozoa in check. This isn't just a simple niche that another organism can easily fill. It's a complex, specialized interaction. Removing an entire massive niche occupied by disease-carrying mosquitoes, even if it's a fraction of all species, could indeed cause significant, long-lasting ill effects.
I appreciate your emphasis on specific, intricate ecosystems. However, I remain convinced that the precision of modern gene drive technology and Wolbachia strategies significantly mitigates the risk of widespread ecological fallout. Gene drives, for instance, are engineered to target highly specific species, such as Anopheles gambia for malaria or Aedes aegypti for dengue and Zika. We're not talking about a blunderbuss approach here. Scientists are actively researching countermeasures for reversibility, meaning if unforeseen problems arise, we could theoretically reverse the effects or introduce alternative controls. Andrea Crisanti, a molecular parasitologist, even suggests that the genetic modification might not reach all areas where a species is found, preventing total eradication and allowing for natural checks and balances if a complete void proves problematic. Moreover, Wolbachia bacteria, they don't aim for extinction at all. Their goal is to make mosquitoes resistant to parasites, effectively stopping disease transmission without eradicating the mosquito population. The trials, like the impressive ones in Colombia, demonstrate how this can dramatically reduce disease rates while keeping the mosquito populations largely intact. These are not blunt instruments. They are sophisticated, targeted approaches designed to solve a specific problem, disease transmission, while minimizing broader ecological impact. The idea that these precise, targeted genetic interventions will lead to an uncontrollable species-hopping catastrophe, I believe, mischaracterizes the current state of the science and the safeguards being considered.
That's a compelling argument for precision, but have you considered the serious concerns about the potentially uncontrollable spread of genetically modified organisms, regardless of initial targeting? Gene drives, by their very design, are engineered for aggressive propagation throughout a species and across geographical borders. While scientists aim for precision, the reality is that animals don't care about international agreements. The potential for gene drives to unintentionally cross into non-target species, even if considered unlikely by some, remains a profound and difficult to quantify risk. What happens if a gene designed to sterilize one mosquito species accidentally affects a beneficial pollinator species that shares some genetic commonalities, for example?
Right.
The legal and ethical landscape around this is complex and largely untested. It's worth noting that the European Union and some other nations have already rejected the release of gene drive modified creatures within their borders precisely because of these unknown risks and the inherent difficulty in recalling such a release once it begins. We are venturing into uncharted territory. To assume that these complex biological systems will behave exactly as predicted, especially given humanity's long history of ecological interventions going wrong, it seems, to me, overly optimistic. It feels like a gamble with consequences we don't fully grasp.
I understand the gravity of venturing into new scientific territory and the call for caution. I do. However, I believe we must directly confront the sanctity of life argument when faced with millions of human deaths and widespread suffering caused by mosquito-borne diseases. It becomes a matter of ethical priority, doesn't it? A choice between mitigating unimaginable suffering now versus theoretical, potentially reversible ecological risks later. Andrea Crisanti poses a critical question. If we had already wiped out Aedes aegypti, would we ever contemplate reintroducing them? When you reverse the argument, the answer seems clear. Reducing human suffering and promoting global health is, for me, a primary ethical consideration that profoundly outweighs abstract philosophical concerns for a creature that primarily serves as a vector for deadly diseases. We are talking about saving lives on an unimaginable scale, offering a chance at health and prosperity for entire communities.
While the desire to combat disease is deeply understandable, I reiterate that the profound ethical shift involved in instrumentalizing extinction is not an abstract concept. It represents a new and potentially dangerous threshold for humanity. It sets a precedent that could diminish our reverence for biodiversity and open doors to other forms of biological engineering with unforeseen consequences. Furthermore, the fascination with sexy, high-tech solutions like gene drives often overshadows and, tragically, underfunds unglamorous but highly effective public health measures.
Okay.
Experts like Steve Lindsay, a public health entomologist, and Trudy Lang, head of the Global Health Network, strongly advocate for traditional methods: widespread insecticide-treated bed nets, targeted indoor residual spraying, habitat management to reduce breeding sites, robust community education programs, and continued vaccine development. These approaches offer proven results without the irreversible ecological and ethical risks. Consider the success of traditional vector control programs in places like Singapore or parts of South America, which have achieved significant disease reduction through integrated strategies focusing on source reduction and community engagement, proving that high-tech isn't always the only or best answer. Catherine Hill, a professor of entomology at Purdue, herself once focused on killing mosquitoes, but had an epiphany, as she put it, that she was morally not okay with it anymore. Her team is now developing insecticides that suppress disease transmission without killing the insect. This highlights that there are alternative, less drastic paths that honor both human well-being and ecological integrity. Why leap to irreversible extinction when other, proven, and less risky solutions exist or are being developed?
We've certainly delved into the profound complexities of this issue today. Given the catastrophic human toll that mosquitoes inflict globally, and with increasingly precise and targeted scientific tools becoming available, the prospect of alleviating immense suffering by controlling or eliminating specific disease-carrying mosquito species is, in my view, a compelling and responsible path forward. It's not about being cavalier with nature, but about making informed, ethical choices when faced with an unparalleled humanitarian crisis, even if those choices come with complex questions.
And I maintain that while the desire to combat disease is deeply understandable, the profound ecological interconnections and the unpredictable nature of tampering with entire species demand extreme caution. The potential for irreversible damage and unintended consequences, alongside the ethical implications of intentionally wiping out a life form, suggest that the cure might carry risks that could ultimately outweigh the disease, especially when less drastic, effective alternatives are available and continually being developed.
It's clear that the question of mosquito eradication remains a complex and multifaceted dilemma, with credible arguments on both sides. The various expert perspectives presented in our source material highlight that there is no easy answer, and any path forward requires ongoing scientific scrutiny and robust ethical debate.
Indeed. It truly challenges us to think deeply about our role in nature, balancing our humanitarian impulses with our responsibility to the global ecosystem.
For our listeners, to help deepen your understanding and improve your listening skills, let's reflect on 3 terms central to our discussion today. The first is utilitarian, referring to an ethical framework that prioritizes actions that produce the greatest good for the greatest number of people. For instance, the advocate's position is rooted in a utilitarian ethics. The second term is imperative, meaning something of vital importance or urgency, a command. We discussed how the elimination of disease-carrying mosquitoes is seen by some as a moral imperative. And finally, trophic cascade, which describes indirect effects in an ecosystem. For example, when the loss of a top predator dramatically impacts lower trophic levels, we might ask, would the removal of mosquitoes cause a significant trophic cascade?
Excellent choices. Now, for a simple task to challenge you based on our discussion. Think about the arguments presented today. Can you identify one specific piece of evidence or a particular expert's view from each side, the argument for elimination and the argument against it, that you found particularly impactful? And why? We encourage you to reflect on this and maybe even try to explain it to someone else, to really solidify your understanding.
Thank you for joining us on the debate. We hope this discussion has illuminated the complexities of this issue for you and encouraged you to think critically about these challenging questions.
Congrats! You just crushed your 1% for today. If you're loving this podcast, show that subscribe button some love. And don't forget to hit the bell so you never miss your daily dose of 1%. That's it for today. Take care, keep growing, and we'll see you tomorrow.